when we graph cube root and square root graphs, there's three things I'm going to ask you to do. First up, I'm going to ask you to make a sketch of the graph. That's going to include 1 point. The rest of it will be just a sketch. The reason I'm okay with you just doing 1 point and the rest of it is a sketch is because you're also going to provide the second part, sort of a detailed comparison. The final and third part you're going to be doing is describing the domain and range. So we're going to take a look at a few different examples. If you need to stop the video early, if you get it, that's fine. If you want to skip around to the harder examples, that's fine too. Also, I'm going to do this without even touching my graphing calculator, just to show you that it can be done. At the end, I'll show you a couple things to take a look at on the graphing calculator, so if you're looking for that, maybe just skip to the end of the video. Anyway, let's go ahead and start with our first couple easy examples. Now, I'm going to do my directions a bit out of order. The first thing I'm going to do is I'm going to make my comparison first. And so what I'd recommend you do, like we've done with other graphs we've taken a look at throughout the year, is draw an arrow pointing to the number specifically, so we'll be able to tell specifically not only what's happening to the graph, but also which number is causing that. So in this case, our square root graph has an a value. That a value is going to have the effect of either stretching or compressing the graph. So in this case, because our a value is less than 1, I'm going to say that this graph has been compressed. Okay, meaning it's not going to be as steep as our parent function that we took a look at. The other thing you may want to do is notice that this is a square root graph. Our basic graph of a square root graph was kind of that hook, that half of a sideways parabola. So you may want to just make a note of whether you're dealing with a square root or a cube root graph. So that's really all I can do for my comparison. It's just been compressed. Next up comes the actual graphing part. Remember I said I want to see 1 point, and that point that I see is going to be that sort of vertex or that starting center point number. Now for our parent function, it was at 0, 0, and it will remain there unless we've done any shifting. Nothing has been shifted for this graph, so my starting point will be at 0, 0. We know this is a square root graph and we have the basic hook shape, so all I'm going to do is just make a really rough sketch of what that's going to look like. If you want to be more accurate, again at the end I'll show you some ways you can find some points in your calculator, but I'm okay with you just doing that. Now there was one more part to this, and that was finding the domain and range, so let's go ahead and do that as well. Do make sure you label which one's which, so I just like to use D and R to label that, and then don't forget to include X and Y. Domain is always X and range is always Y. Now again, if we haven't done any shifting, those remain at 0, 0. So my X, what I'm allowed to plug in, needs to be greater than or equal to 0. I can't plug in anything negative. You can also think visually, and look at the graph left to right. I can see that left to right the graph sort of starts from 1, or from 0, sorry, and goes to the right. In other words, did I say 1 again? Starts from 0 and goes to the right. So X has to be greater than or equal to 0. Your range, if you think visually, is how high or how low the graph goes. Well, again, it starts from 0 and goes up from there. So Y has to be greater than or equal to 0. Again, I'll give you some hints on some other examples in this video as we go. Oops, let's include those. Okay, so there's our square root graph. Let's take a look at our cube root graph. Okay, again, probably want to note that we have a cube root that we're dealing with. So we know the basic shape. We're going to have that 1 point, and we're going to have that S-curve type shape. So I probably want to make a note about that. Also, I want to see what effect that negative has, and the fact that I have a 3 being multiplied in front. So I'm going to draw arrows to all those things. Well, the negative a value is going to have the effect of flipping the graph. It's going to reflect it. So it's not going to be that same S-curve. It's going to be switched around. And then the fact that we have a 3 in front being multiplied, not the little 3, the big 3, that's going to stretch our graph, making it taller and shorter. If you get what I mean, it's going to be more extreme, I suppose, more stretched vertically. Okay, once again, that's my detailed description. Next up, I'll graph that starting point. It's going to remain at 0, 0 unless you've shifted the graph around. We haven't this time, so let's go ahead and put that starting point right there. Now we know the basic shape would normally be something like this. However, because we've noted the graph has been flipped around, we're not going to have that. It's going to be flipped. And so we're going to start high, kind of cross over, and then end low. And then include arrows because the graph does go on forever. Those arrows tend to point more sideways than they do vertically, so kind of point them off to the side like that. And then finally, we were asked to do domain and range. It's really easy for a cube root graph. We're allowed to take the cube root of anything we want, including negatives. We can't do the square root of a negative number and get a real answer. So for cube root graphs, our domain is always all reals, and our range is also always all reals. We can plug in any number we want for x, positives, negatives, whatever, and we can get out any answer that we want. Also, if you think visually, remember, domain refers to how far left or right the graph goes. Well, it goes forever left and right. There's no stopping point. Range is how high or how low the graph goes, and even though it's going up and down slowly, it does go up and down forever. So those are some basics about graphing cube root and square root graphs. I know I said I was going to do a couple other examples. This video is getting long enough, so let's stop this video here. We'll do a couple other examples for where the videos get a bit more, or where the equations get a bit more complicated.